Good afternoon, dear students. So today we are going to start uh, introduction part of soil mechanics and geotechnical engineering. So what we actually going to learn in this chapter is introduction about soil mechanics, soil and its constituents, weathering of rocks, soil and its various types. So what actually we means by soil mechanics? Soil mechanics is defined as a branch of engineering science which enables an engineer to know theoretical or experimental behavior of soil under the action of loads. Loads may be static in nature or dynamic in nature. Number two, gravitational forces. Number three, water, and number four, temperature. Simply speaking, it is a knowledge of engineering science which deals with the properties, behavior, and performance of the soil as a construction material or a foundation support. So, as per Terzaghi, Terzaghi is also known as a father of soil mechanics, a famous scientist which defined soil mechanics as follows. Soil mechanics is application of laws of hydraulics and mechanics to the engineering problem dealing with the sediments and other unconsolidated accumulation of the solid particles produced by mechanical and chemical disintegration of the rocks. So, dear student, with the recent advancement in the science of engineering, the design and execution of the large project, which at time were considered beyond imagination and control, have now become quite common. Nowadays, skyscrapers, subways, maritime structures, offshore structures, dams, and bridges spanning the sea are some common examples of the large projects. So there arises the need for the design and construction for almost such projects. The engineer have to deal with both the earthen material like soil and rocks, either as a construction material or as a foundation support. So as soon as these infrastructure are coming into picture, like skyscrapers, buildings, subways, maritime and offshore structures, dams and bridges, not only spanning the river but also spanning the sea, knowledge of earthen material like rock and soil for as a construction material or as a foundation support is of prior important. So why we actually study soil mechanics? Various studies, various reasons to study the properties of soil, foundation to support the structure and embankment, construction material, slopes and landslides, earth retaining structures, spatial problems. Various reasons to study the properties of soil. Number one, foundation to support structures and embankment, effects of static loading on the soil mass, shear failure of the foundation soil, settlement of the structures, stability criteria solution. There should be no shear failure of the foundation soil. The settlement should remain within the permissible limit. For firm soil, we go for a spread footing, that is also termed to be the spread foundation, and for soft soil, we go for the pile foundation. That is basically termed as, that is basically the vertical members transferring the load of the structures to the ground, that is raw. So this is an example. In a figure you can see the shear failure of the soil in a retaining structure, earth retaining structures, and for foundation. So various reasons to study the properties of soil, foundation to support the structures and embankment, effect of dynamic loading on a soil mass. For design and construction of the roads, following must be considered: compaction characteristics and moisture variation. Why we study soil mechanics? Construction material. So soil is being used as a construction material for subway or highway pavement, for subgrade of a highway pavement, in a case of land reclamation and in a case of earthen dam. This is a figure of, and this is a diagram of earthen dam. You can see a pavement over here, gravel bed, rock facing. This is a reservoir, this is clay core. Major cause is the moisture variation resulting in slopes, and for in the case of slopes and landslide, major cause is the moisture variation resulting in the reduction of the shear strength, increase of the moisture, increase in the unit weight. Excavation of the trenches for buildings require paste excavation. There's the lateral base, and these two are the sheet piles. So landslide of a parking area. This is a diagram of landslide of a parking area at the edge of a steep slope, mainly due to the increase in the moisture content. Uh, Fourth one is an earth retaining structure. Example, retaining wall are constructed to retain the holds backs any material, usually earth, and prevent it from sliding or eroding away. So in this figure you can see very clearly these are some reinforced soil structure and these are some earth retaining structures. A special problem like effect of river water on a soil mass. Number A is scouring causes increase the flow velocity due to obstruction. Fineness of the riverbed material. Stability criteria. The foundation of the pier must be below the scour depth. Land erosion. So this is the soil under the action of water scouring. So in this figure you can see foundation material has been scoured with the action of river water in this superstructure bridge. This picture is clearly depicting the action of water on a soil termed to be the erosion of the soil. Effect of frost action on a soil mass, reduction of the shear strength, settlement of the structure in a summer, lifting up of the structure in a winter, heaving due to the formation of the ice lenses, increase of moisture due to down. Downing means melting. So in this figure you can see the ice. In this figure you can see the ice lenses. Soil subjected to the low temperature, that is called a frost action. What are different objectives of the soil mechanics? Perform engineering soil surveys, develop suitable soil sampling devices and methods, develop suitable soil testing devices and methods, determine the physical properties of soil, evaluation and interpretation of the test result and their application to use of the soil as foundation support, behavior of the soil under loads and forces, adopt suitable soil conservation techniques, sedimentation control of the dam reservoirs, select a site for disposal of the solid waste, that is landfills, and to deal with their design, operation and post completion of the problem of the landfills. What do you mean by weathering of the rocks? Weathering may be physical in nature, weathering may be chemical in nature, and the rock cycle we are going to learn about all these things. So students, you all people might have gone through these cycle of weathering, then also I am discussing it over here. First of all, formation of magma takes place, and crystallization of magma causes the formation of intrusive igneous rocks, rather due to the action of consolidation. This intrusive igneous rocks is being converted into extrusive igneous rocks, and later on its weathering occurs. Once the weathering of igneous rocks takes place due to action of certain physical phenomena or certain chemical phenomena or biological phenomena, then afterwards transportation, deposition, lithification takes place, and the igneous form is converted into the sedimentary rocks, and due to the action of heat and pressure, metamorphosis process occurs, and later on metamorphic rocks is formed. So this cycle keeps going on, and formation of igneous rock, metamorphic rocks takes place. You all people might have learned this topic in geography also, and if you all people have gone through the subjects of geology, then also you have learned about the weathering of rocks. So weathering is a process of breaking down the rocks by physical and chemical process into the smaller particles. There are two main types of weathering: physical or mechanical weathering or chemical weathering. Biological weathering is caused by the activities of the living organism, for example, the growth of roots or by burrowing of animals. Tree roots are probably by the most occurring but can often be by animals. Physical weathering or mechanical weathering is the disintegration of the rock into the smaller particles through physical processes, including the erosive action of the water, ice, and winds, opening of the cracks as a result of unloading due to the erosion of an overlying soil and rocks. loosening through the percolation and subsequent freezing and expansion of the water, thermal expansion and contraction from day to day and season to season, landslides and rockfalls, abrasion from the downhill movement of the nearby rocks and soils. Chemical weathering is the disintegration of the Chemical weathering is the disintegration of the rocks through chemical reactions between the minerals in rocks, water, and oxygen in the atmosphere. So, dear students, this is a rock cycle. I am going to explain it very clearly. First, the formation of igneous rocks takes place, and due to the weathering and erosion, sediments, igneous rocks get converted into the sediments, and these sediments, after deposition and burial compaction and cementing process, get converted into the sedimentary rocks. And due to the action or process of metamorphosis and action of heat or pressure over there, these sedimentary rocks are converted into the metamorphic rocks. Once these metamorphic rocks melts, they get converted into magma or soil, magma or lava, and their solidification against converted into the igneous rocks. Now, what is soil? What are their form? How they are formed? Their differentiation depending on their geological constitution and engineering consideration. So, soil, according to engineering point of view, is defined as a material by means of which and upon which engineers build their structures. The term soil includes entire thickness of the earth crust, from the ground surface to the bedrock, which is accessible and feasible for practical utilization for the foundation support or as a construction material. It is composed of loosely bound mineral particles of various size and shapes formed due to the weathering of rocks. So, how this is a process how soil is formed, how soil formation takes place. Soil is generally formed by the disintegration and decomposition weathering of the rocks through the action of physical or mechanical and chemical agents which break them into the smaller and smaller particles. So in this figure you can see a disintegration of the bedrocks. Organic material facilitates the disintegration, horizon formation, and developed soil supports thick vegetation. So these are some different stages of the weathering of the rocks and formation of a soil. Formation of a sound massive rocks, some fissure in the upper zone, slightly weathered rock, later on moderately weathered rock, then highly weathered rock, and then completely weathered rock, and after all you get a residual soil, that is the oldest soil, and after at the top of the earth crust you will get the top soil, highly organic in nature. So here comes the types of soil depending on their geological consideration. Basically, the history or the formation of the soil deposits greatly influences its properties and behavior. The properties of soil highly depend on the process through which the soil deposits have been developed. Following are the types of soil based on the geological agents or process through which the soil deposits have been developed. So, what is basically glacial soils? These are the types of soils which are deposited and transported by the action of glaciers. Where these types of soils are found, if you're in Uttarakhand, you will go to the Gomukh or Gangotri glaciers. All these glaciers are present in the hilly terrain only. Such types of soil will be found. So these deposits consist of rock fragments, boulders, gravels, sand, silt, and clay in various proportion. That is heterogeneous mixtures of all size of particle, and this is termed to be the glacial soil. You will basically found these types of soil in hilly terrain where glaciers are formed. So residual soil, these types of soil is found on nearly flat rock surfaces where the weathering action has produced a soil with little or no tendency to move. Residual soil also occurs when the rate of the weathering is higher than the rate of removal. Alluvial soil, the soil transported and deposited. If the soil is transported and deposited by the water, it is called alluvial soil. As the flowing water, stream or river lose velocity, it tends to deposit some of the particles that it was carrying in suspension or by rolling, sliding, or escaping. Along the river side, coarser or heavier particles are dropped first. Hence, on the higher reaches of the river, gravel and sand are found. However, on lower parts, silt and clay dominate, where the flow velocity is almost zero or very small. Wind-blown soil or aeolian soil, the soil transported by the geological agent like wind and are subsequently deposited is known as wind-blown soil. There are basically two main types of wind blown soil, that is dune sands and Lewis. So these dune sands are found in the arid parts of the world where wind is continually forming sand deposits. So dear students, you will get such type of dune sands in a desert area like Rajasthan in India, Qatar. You will get such type of soil. So in this figure you can see the figure of sand dunes in a desert of Qatar. Loess. Loess is basically a silt, accumulation of silt. Accumulation of wind-blown dust, mainly siliceous silt and silty clay laid down in a loose condition. This is known as Lewis. So saturated Lewis is very weak and always causes foundation problem, that is of liquefaction. Colluvial soil, the accumulation formed by the rock fragment and soil material resulting from the mechanical weathering of the rock is known as colluvial soil. So as far as engineering consideration is concerned, we classify the soil as, first of all, as clay, which particle size is less than 2 micron. It composed of very fine particle less than 2 micron in size. They are flaky in shape, therefore have considerable surface area. These surfaces carry electrical charge, which helps in understanding the engineering properties of the clay soils. In moist condition, clay becomes sticky and can be rolled into the threads. Due to the electrical charge, clay show high interparticle attraction and thus exhibits the sufficient cohesion. It has high dry strength, low erosion, low permeability, good workability under the moist condition, and can be readily compacted. Also susceptible to the shrinkage and swelling. Clay soils commonly have brown color. So this is an example of clay particles. Electrical charges on a particle and interparticle bonding can be very clearly seen in this figure. Number 2 comes the silt particle. It basically lies between 2 microns to 60 0.002 mm to 0.06 mm. It composed of very fine particles ranging in between 0.002 and 0.6 mm. It has high capillarity, no plasticity, and very low dry strength. It possesses properties of both clay and sand, that is, it shows slight cohesion and also friction. The color of the silty soil is mostly brown. It consists of particles ranging in size from 0.06 and 10 mm. It has a gray color. The particle may be rounded to angular in shape. It shows no plasticity, high strength in a confined state, and has considerable frictional resistance. It has a high permeability and low capillarity. Sand is the most wanted construction material. Abundant quantities of the sand are available in deserts and riverbeds. Gravel, size lies between 2 mm to 60 mm. They consist of particles varying in size from 2 mm to 60 mm. They form a good foundation material. They show high frictional resistance. The frictional resistance depend upon the particle size and shape. The gravel produced by the crushing of the rocks and angular in shape, while those taken from riverbeds are sub-rounded to rounded. They show very high permeability. When sand and silt are mixed with gravels, their bearing capacity is further increased, but permeability may be decreased. Cobbles and boulders, particle larger than the gravels, are commonly known as the cobbles and boulders. Cobbles generally range in size from 60 mm to 200 mm. The material larger than 200 mm is designated as boulder. Organic matter, the main source of organic matter is plants or animal remains that are added to the soil. When these organisms die, plant decomposes at a slower rate than the animal remains. Commonly about 12 inch of the soil from the top surface has a major concentration of organic matter. It undergoes large volume changes under the loads and contain high natural moisture content. The strength of a soil is very much reduced when the concentration of the organic matter is more than 2% and soil is considered unsuitable for foundation support. So basically the soil types based on the grain size limits are according to ASTM and ASDO classification also. But I think I have to discuss all these things later on, and where you have got a certainly there is a chapter on classification of engineering classification of soil, so I would be discussing these things also later on. But now we will see the nomenclature of the material soil types depending on the range of. So it is termed to be gravel if the particle size lies between 75 mm to 4.75 mm, and as per ASTO classification it should be larger than 2 mm. And in nomenclature it is given coarse sand if the size lies between 4.75 mm to 2 mm, and as per ASTO classification it should be between 2 mm to 0.4 to 5 mm. Medium sand as per ASTM, if it lies particle size lies between 2 mm to 0.425, or I should say 4.25 425 micron. And fine sand if particle size lies between 425 micron to 75 micron, and as per ASTO classification also. And silt, it is termed to be silt if the size lies between 75 micron to 5 micron. Same is the case with ASTO classification. Clay if it is less than 2 micron. Here it is something is clay size if the particle size between 5 micron to 2 micron. And for colloids it should be smaller than 1 micron also. So these are some classification, engineering classification of the soil. Certain agencies like American Society for Testing and Material and ASTO, American Association of State Highway and Transportation Official, they have given certain classification of the soil. So dear students, this is just an introduction to the subject. Later on we are going to get the in-depth knowledge of these subjects where we have different subtopics. We have got a certain chapter on classification of soil. There also I will discuss all these things. Today just I have introduced the subject. I have told you all people the types of soil, their classification, their nomenclature, and how they are formed. This is just a basic of the subject. Later on I will discuss the technical aspects, engineering aspects of the subject, and it seems to me you all people will enjoy the subjects a lot. Okay, thank you for listening to me.